Not necessarily. You'll have to ask him, but I think we're about to start. Oh. It's not there. Why wouldn't you change it?
Sorry. I just wanted to check and make sure that that's the right one on the server, or am I just kind of stuck with looking at it? We do it. That's good, then don't worry about it.
Yeah. When you're ready. We're recording. Okay. Good afternoon, everyone. Can you hear me all right? I recognize most of you, but for those of you that don't know me, my name is Kurt Swartzlander. I'm the city manager here in the Shores. Today's presentation, or presentations and meeting, was put together at the request of Commissioner Bryan. A few meetings ago, he brought up the idea of trying to get people information and to come together to try and work together. And he'll go into more of the objectives of today's meeting in a little bit. But I just wanted to cover a couple of, I'll call them legal disclaimers for this meeting. So the city is not here today to recommend one engineer or one contractor. We don't have an opinion. That'll be up to each individual property owner to make those selections. And today, you're going to hear different design concepts, and you may hear why people chose to go with a particular design, but we're not here to argue about which is better. You might hear some information where one person says they went with this because they felt it was better. Keep in mind, that'll be their opinion of why they chose the wall they did or why it was designed the way it was. So I don't expect it to be uncivil, but let's just keep it civil in case there's disagreements. Let's just agree to disagree. And then I believe we have 5 or 6 presenters tonight, and we're going to try and keep it to a 10-minute presentation per, with Q&A at the end of each presentation. So you can ask specifics about those presentations. With that, I'll turn it over to Commissioner Richard Bryan.
Thank you, Kurt. I'd like to thank everybody for coming. I hope you'll find it valuable. I'm going to start out with the objectives. I think everyone that actually saw everyone that saw the invitation has already seen the objectives, but I'm going to cover them. Basically had 5 objectives for this meeting, and I'm going to dispatch with the temporary cofferdams very quickly. This is really more for contractors, and if they have an issue with having to move their equipment on and off the beach due to tides, you may want to look at using a cofferdam. There may be permitting issues. We're just mentioning that, and the contractors need to follow up if they want to do that. The trap bags are coming down, and there's like, I don't know, maybe 5,500 feet of trap bags in between Daytona Beach Shores and New Smyrna Beach. I think there's twice that much that has already been ordered or in a warehouse. So all that's going to sit in the warehouse in Orlando as a sunk cost. And it's conceivable that they could be used for cofferdams, but there may be permitting issues, there may be other issues. So it's just there for a contractor to take into account if they're going to have issues with having to move their equipment a lot because of the tides. The highlighted objective is one of the most important objectives. If neighbors get together and build a common seawall, there's a significant amount of money to be saved. And it depends a lot on how long the common seawall is and how many neighbors there are. One of the big savings is if everybody does their own seawall, there are going to be significantly long return walls at each property line. In fact, there's an example of people in the shores that have two different designs, a steel design and a composite design, and they actually have two return walls at a property line, one steel and one composite. So by getting together, neighbors can save a lot of money. We're going to have an example of a neighborhood down in Smyrna Beach that were 36 property owners, and another, I think, a condo. They did get together, and they actually formed an LLC. They divided up the row of homes into three, and each one had a captain to try to get everybody on board. So that's an example of cooperation, and they're going to save quite a bit of money. Another example is in the shores for revetment. They want to build a revetment. Those single-family homes south of Frank Rendon have, I guess they maybe don't have 100% cooperation yet, but I'm guessing they will. So they're going to save quite a bit of money by getting together rather than everybody doing their own thing. So that's a very important objective. Perhaps an even more important objective is the second one there. In my opinion, and while I'm expressing opinions, I want to just say that I'm one council person. The council only expresses an opinion at a public meeting by a majority vote. So my opinions don't necessarily represent the opinions of the city council. But in my opinion, when we get to the end of this next hurricane season, there are going to be a lot of properties that don't have any permanent armoring, even some properties that think they're going to have it. There'll be some have already started, but there are a lot that haven't even started, don't even have an engineer. So it's extremely important that there be a temporary armoring alternative that will protect against significant upland erosion through the hurricane season. I mean, there's no 100% guarantee, but in terms of what's likely to occur, it should protect against what's likely to occur. And I'll talk a little bit more about that, but I think the county has properties that they need to protect, and I think the city has properties, so hopefully we can get some analysis going that will say what will fit that bill. And I think, as you all know, there's been a significant amount of gouging in certain specific categories. I think one of the easiest to determine is surveys. The survey prices are all over the map. And I know one condo that basically they ended up getting their survey for $6,700, but they were offered this great deal. If you want it right away, we'll do it for $25,000. And that's sort of an extreme example, but probably sand, particularly the people who bought sand early on, they were paying higher prices. So hopefully we'll be able to help a little bit as far as gouging. And basically what I did, I formed an ad hoc engineering committee, and we started off by trying to evaluate seawalls that, we tried to get as-built drawings of seawalls, and that was difficult. We didn't get very many of them, to see what designs held and what designs failed and what the mode of failure was. That ad hoc committee consisted of 3 Daytona Beach Shores residents. One of them is a structural engineer, one of them is a civil engineer, and the third one is actually here tonight. John Taylor is he has a degree in chemical engineering. He's done environmental engineering work. So we've talked to a number of the engineers, a number of the contractors, and we've been able to form some opinions in general about seawall design. And I think all 4 of us know a lot more about seawalls now than several months ago when we started. The first objective is what we're going to spend the most time on, and that's gathering information about existing seawall designs. Hopefully we'll get some pricing, and that's what I'm going to go into. So the next slide, it's not actually a slide, it's a video. This is kind of to remind you of the devastation, but there are some significant points along here that I want to point out. This is the destruction down in Wilbur. Let me see if I can get this. As you know, did you want a maximum? Yeah, okay, thank you. There you go. I'm going to back this up a little bit. This frame shows this happens to be the white surf, and this was taken. These helicopter views were taken after Nicole. And after Ian, they put this rock revetment, happened to be coquina. And as you can see, that maybe 75% of the property was pretty well protected by the revetment. The other 30% or so had a seawall that I guess they thought was going to hold. It didn't hold. And but the main point here is that at least that revetment held against whatever Nicole had to offer. I'm going to talk a little more about revetments later on after the seawall presentation. This is next to Towers 10, a vacant lot that got a lot of erosion. I'm going to stop here at Peck Park. One of the things this shows is this seawall over in the north corner. That's about 51 feet or 52 feet of fairly new seawall. It was installed in the last 2 years. The design is reinforced concrete. It actually suffered some erosion on the north side and the south side of the soil behind it. But it stood, whereas the bottom of the south, maybe 150 feet or so, was demolished. I guess what that says is not that a concrete seawall is the best, but this particular design, protected against Nicole, and even with erosion, partial erosion on the north and south ends. That wall happens to be leaning a little bit to the west now, but it's one example of a seawall basically that held.
Hey, Richard.
Yeah.
Just to clarify, the north portion was a separate, newer one.
Yeah.
The other part was an older,
Yeah, right. It was built in the last 2 years. And the other was older. I think it was designed on top of an old seawall, which is basically a no-no. But the other point that I wanted to make here, that there are properties adjacent to Peck Park. See this one? And the one just to the north of that property. And I think this is St. Croix, is that right? Yes. On the north, yeah. But those three properties south of St. Croix could benefit if they got together and built a common seawall.
If we knew who the owner of the lot was.
Yeah, well, St. Croix probably doesn't need to be a part of the common seawall, I think. But, yeah, anyway, that's just an example of a row of properties that could benefit.
I should mention that that erosion has gone back further since Nicole quite a bit.
Yeah. Yeah, I mean, that's another reason why there needs to be temporary armament that's going to protect, because, you know, these properties, probably none of the properties, none of those three will actually have a permanent seawall by the end of the hurricane season. That's just my guess. These are the, I think approximately 30 homes south of Frank Rendon Park, and north of St. Kitts. You can see the significant erosion. I think on average, these properties lost about 60 feet total, approximately 30 feet from Nicole and Ian, and from Ian and another 30 feet from Nicole. And you can also see that the erosion, it's back to the property, that's called an escarpment. That's how, you know, erosion that goes all the way back to, you know, where you see a wall of sand. And you can see from this picture that the escarpments are not in a row, they're staggered. And I'll tell you a little bit why that's an issue. But if we go forward just a little bit here. That property, which happens to be 2727 South Atlantic, put these trap bags out after Ian and before Nicole. I think the configuration is one trap bag on top of two. I'm not 100% sure, but I think it is. So it's like, if that's the case, or whatever the configuration is a configuration that protected against significant erosion through Nicole. And right now, it's the only property that I'm aware of. And if any of you know any other properties that have either a two trap bag configuration like the county's putting out, or a 1/2, I'd be interested in knowing that, because that may be important empirical data that says what temporary armament might get people through the next hurricane season. And this is just some more of the single-family homes showing you how the escarpments are uneven and the kind of damage. The one at the very end next to Frank Rendon got a lot of damage. This row of properties, what you're looking at in the middle is what used to be Tracer Island, plus the property to the south of it. That's about 700 feet of property.
So the people streaming can't hear you.
Oh. Can you hear me now? Okay.
This is,
To the south of that, there's property, and to the north of that, there's property. We can go a little further north. This is one prime example. If these neighbors got together and cooperated, there's probably 2,500 or 3,000 feet there. If they built a common seawall, they could save a considerable amount of money, and probably aesthetically, it would be more pleasing to people rather than having a hodgepodge of designs. That's up to people that would judge those things, you know, the property owners, the aesthetics of it. I don't have much of an opinion one way or another on the aesthetics. And they can actually get a better design. They can put more time and effort into the engineering by splitting the engineering costs and so on. So that's an example of a fairly long stretch in the shores that could benefit. You know, that's some more. That's the end of the video. If anybody has any questions, yeah, I'll take them. Just raise your hand. Yeah.
When you talk of, when you talk of a,
Could you just identify who you are?
my name is Jeff Anton, Paragon Engineering, several walls in design and going into construction. When you talk of common walls and, you know, there's the owner responsibilities. We saw a number of properties that had, you know, adequate seawalls and inadequate returns. They would have done fine had the neighbor gotten demolished and then flanked, is
Right.
the term I use.
Right.
You flank and get erosion from behind. And by discretizing the properties and the concept of good fences make good neighbors, where my property, I'm still responsible to take care of my own. You know, over the long haul, there's maintenance issues, there's items of that. In terms of forming an LLC and maybe responsibility and ongoing, if you would, association dues for the maintenance, short of that, how do you propose, you know, cutting these up, especially some of these undeveloped properties that might end up with unity of title and have one big development or 3 separate developments, and those neighbors eventually might not get along.
Well, if they don't get along, it's not going to happen. Yeah,
I mean in the future.
Yeah, in the future.
The 3 of us might get along today, but tomorrow he might move and.
Well, it has to be worked out, just like any, you know, any HOA or whatever. You know, those issues just have to be worked through, and it's not. It'll be easier for some group of people than others, and all I can say is, if it does happen, the total dollars spent will be a lot less, and they'll probably have a better engineering design. You know, what happens in the future has to be contractually ironed out as far as, you know, I'm not going to speculate on what would be the best arrangement tonight. You know, those are things that just have to be worked out. All I can say for sure is, initially they're going to save a lot of money. They're going to get a homogeneous seawall rather than sort of a hodgepodge of steel and composites and concrete. And I think for some people that'll be of value, and probably get a better engineering design. They can afford, for example, to have an engineer do the design, have another totally uninterested engineer who's not looking for business in the shores review that design, which to me, if I were a property owner, I would want to have that done, even for a single family. Okay, I'm going to move on into, I guess, what you might call Seawall 101. The engineers can take a short nap if you want. This is pretty basic. This is like a cross-section of a seawall. There are sort of 5 kind of important numbers. Obviously, the top of the seawall, which is here is the top of the cap A, that elevation, and there's a coordinate system called NAVD that all these numbers would be expressed in. That coordinate system some people think of above ground. Well, the sand is not static. It moves up and down in elevation, so it's not a very good reference point. NAVD is a fixed point. It doesn't matter where the sand is. The zero NAVD is the same. And physically, it's approximately the mean high water mark, just to give you some feel for what it is. Inside that cap, there's typically the top of a sheet. That elevation is at B there. Numbers between A and B are typically like a foot, maybe 2 feet. C is just where the sand happens to be whenever that's, the analysis is done. It's kind of unimportant because what drives the design is D, which is basically, that's the lowest level of the sand next to the seawall that you can expect over time. It's like a worst case level. And unfortunately, it's not totally something you can plug a number into a formula and every engineer is going to get the same answer. There is a document called the 100-Year Storm, and it has numbers in there, so if people get at it with that document, they will get the same answer. At least to the extent that document has every, whatever they call the markers, I think they're every 1,000 feet, what that level is. And extrapolating to the specific site, I guess there could be some difference in opinion. D drives the design because the difference between D and A says basically, how long that sheet needs to be. If there's like a 4 foot of difference, that could dictate maybe as much as an 8 foot difference in the sheet size. So it's a significant cost driver. And E is just the bottom of the sheet in NAVD coordinates. We sent a questionnaire to all the presenters and potential presenters and asked for a bunch of information, including those numbers. And I think at least some of the presenters will say what those numbers are for their design. And I'll be covering one of the properties. And I'll spell out those numbers for that property, which happens to be Twin Towers. This is a revetment, and I think I'm going to save what I have to say about revetments until after the Seawall presentations. So I'll turn it over to Jeff Anton. Jeff is with Tarragon Engineering. He'll tell you the properties he's working on. Towers Grand is one of them.
Thank you, Commissioner, for hosting this meeting. I think it's very important for the professional and construction community to get together and discuss these issues because they do have ramifications 50, 60, 70 years from now after we're all gone and the people who are behind us. My name's Jeff Anton. I own Tarragon Engineering. We're a specialty marine engineering firm who do marinas, docks, seawalls, predecessor companies dating back to 2007, back to 2016. We've been exclusively doing primarily seawalls, but marinas as well, and a large number of residential docks. I hold a master's degree in coastal engineering from University of Florida, 1992. Go Gators. I have a bachelor's of civil engineering from the Ohio State University. Like I said, I've been in this field for quite some time. Currently, we are designing or have under contract or out to bid reconstruction of 9 walls. Some of them what I call major walls. Those would be the ones that are over 13 feet. Much higher loads, as we all know, and There's 2 replacement walls of walls that are intact but irreparably damaged, 2 walls with repairs, and 1 new wall where one hadn't existed prior. We are hoping to, of course, pick up some additional projects. I am, by the way, on a number of these walls working as a subcontract designer to Keystone Engineering, who I appreciate very much, kind of helping us navigate the community. With regard to price gouging, one of my concerns isn't so much price gouging. There's a lot of forces that have come to bear in the market. A lot of contractors, a lot of engineers from across the state. My concern more is kind of maybe a gouging of quality, if you will. I've seen major marine contractors with a lot of experience, some very, very good engineers who I respect highly, putting some designs out there. I've also seen guys put in a bid to some of my clients saying, hey, I'll replace your garage door, and because I used to do that last week, and this week I'm putting in seawalls. So there is a wide berth of those. It's kind of a caveat emptor. There is nothing really that governs seawall design in the state of Florida. Florida Building Code doesn't address it, other than maybe hydrostatic pressure in retaining walls. Other than that, there is a severe lack in the state of oversight of design, checking it. At least, you know, buildings, building codes, structural engineers have to deliver a product. Not so with seawalls. So it is, your only recourse as owners is the tort. You only have a court system to protect you. There's not much in building departments, there's not much in DEP that actually reviews design. In that, you're relying on the experience and the integrity of your engineer and of your contractor, and make sure that your engineer is looking over your shoulder and looking over the shoulder of the contractor. Saving money is a consideration, but engineering is the art of right sizing. If you have 18 tons of gravel to move, are you gonna buy a Tacoma, or are you gonna buy a triaxle? So if you have a 20-foot high wall or NAVD 20 wall, are you gonna just kind of get something off the shelf, or are you going to really engineer it, as opposed to maybe something in the residential where some of the more off-the-shelf stuff will work and work adequately? So optimizing and fitness for purpose. Again, I implore owners, you are your own protection. Again, you and your attorney, which you don't want to bring into this situation. And the problems are only going to manifest when Nicole and Ian come back to town. And that could be 40 years from now. So as far as that's concerned, the temporary armament, we do have problems in the state. FDEP has such severe limitations on armament, 4-foot high vinyl sheets that can be removed, and that's gonna stand up to Nicole. A couple of sandbags, and then you have to be lifted. Those did nothing. So really, and that's done through your state representative, is to put pressure on DEP. I'm gonna get into my presentation. I'm gonna do this now quickly, 5 minutes. Football launch. Rather than talk about all the projects that I'm working on, where's my IT guy? How do I get this into full screen? Okay. Rather than talk about the specific projects that I'm doing, because we're all doing specific projects and we all have our technical things, I'm going to talk about, from my perspective, trained coastal engineer, of what I consider maximum service conditions over the design life of the wall. 100-year storm event at minimum, and what are the conditions the wall is likely to see. and the environmental conditions in which it serves, and the risk of loss of what it's protecting. Obviously, a large residential backyard is not going to bear the same as some of my clients here. I have pools and a number of other very expensive infrastructure that was damaged. Commissioner Bryan mentioned the maximum exposure, this scour tow. There's a publication by FDEP. I'll refer you to that. These are our monuments. 92 to 122 covers about Daytona Beach shores. In this last column here, you'll see the 100-year storm designed grade elevation. That is based on University of Florida modeling. That was actually done back in the 80s. And that's an NGVD number, 3.6, so today it's 2.4 NAVD, and that would be the 100-year floor as predicted by FDEP. The number adjacent is the storm elevation, the still water elevation, also an NGVD number. We convert that to NAVD, and you're going to be at 13.5. So that's roughly the design considerations that we were using. Wave loading, I think, is something that's been horribly ignored. We had 8-10-foot waves crash against our walls. The forces generated, I'll let you do your own math, but a 10-foot wave, an 8-foot wave in 10 feet of water at breaking, at impact right on your wall, is going to put about 10,000 pounds per lineal foot horizontally across your wall. If it's coming in at an angle, that's like running a concrete truck on its side down your wall, and those are the forces. That's a very, very important consideration for anisotropic and isotropic walls. The fatigue cycle, the cycle loading, 5-hour tide cycle, 8-second period, roughly, maybe 8 to 10-second period on the waves. That's 2,300 cycles per tide. That's going to be 15,000 to 20,000 potential loads in the course of a storm, like Nicole. At those loads, fatigue is an extraordinarily important consideration. I don't see a lot of that being considered. Hydrostatic loading. I've also seen a lot of walls. I've reverse engineered them and seeing hydrostatic loading, 5-6 feet below ground surface. We had 22 inches of rain in 24 hours. On top of that, we had waves hitting the wall, saturating the ground. And a number of these communities have exfiltration trenches in their backyard. That's not a wall, it's a dam. And you should design and treat it as such. It is very conservative, but again, we are on the ocean front and we are protecting some very, very valuable infrastructure. So, we can say, oh yeah, there's a drainage system, oh yeah, there's weeps. How fast are those weeps going to work in low tide if it's still raining and keeping you full? Again, the most extreme design load that we're going to see. So we look at materials. First of all, we're working with very dense sands here. 50, 60 blow count sands, really? I've never seen it in Florida, but we're seeing it, and that's very good for towing in a wall, so long as it doesn't get eroded. We've got an enormous amount of atmospheric chlorides, the harshest place on Earth. There's a number of publications that show you the various, if you're putting steel. Also steel tiebacks. If you're within 4 feet of the ground surface, you're exposed to high chlorides. And then, of course, reinforced concrete. One crack, you're exposing the internal steel. That's where I saw a lot of previous damage that manifest during the wall. By the way, I led a group of some University of Florida students immediately after the hurricane. And it was Seawall's 101 out there. I mean, if you want to see how to design something, see how it breaks. And we saw every mode of failure. By the way, the corners, reinforce the corners between your main wall and your return walls. So much broke there. And then, of course, one panel breaches forward, and the rest of them breach backwards after you get scour behind it. Composite materials become very popular. I'm not particularly a fan of it. It's an anisotropic material. If you look at the modulus of elasticity and the ultimate tensile stress, you'll see along the panel length, you're at 20,000 tensile strength. Across the panel, you're at 6,800. Couple that with your cyclic loading, especially if you have horizontal loading as the wave progresses, breaking down the wall, and consider what might happen before you just jump into using anisotropic materials. I looked at some of the composite performance, New Smyrna Park. There's some breaking of the sea locks. This is a Daytona Beach hotel. A lot of you know the property I'm talking about. Again, there's some delamination, especially in the middle picture. Looks like it's from horizontal loading and delamination that way. The sea locks and the bowing on it were also stressed. And then there was an incomplete wall in Wilbur. And I will, full disclosure, this was one of my projects. It was a residential project. Yes, I did, and I still will continue to spec composite for lower impact walls, shorter walls that aren't going to be taking 8-foot, 10-foot waves, but maybe 6-foot. This wall was not completed, but it did show a number of where the stress points and where it will fail. Delamination on the bottom left corner and delamination on the right side. I still believe in the material, but its applications and how far you push it, really consider that for your customers and clients. Hybrid concrete and steel and vinyl. It's a wall design that we have. It's using steel as a core, as the main structural core. The concrete and vinyl kind of protect that steel and give an enduring facade. The wall shown on the upper right is one that we finished construction in 2021 in Satellite Beach. It weathered the storm quite nicely. The other one is a true line wall that's up in Ponte Verde Beach. Also survived very, very well. True line being, I think most people are familiar with what that is. That has limitations in terms of height. The industry really needs standards. In the state of Florida, as many seawalls as we have, not to have something. Is that the alarm for me to get? You got the hook? Again, I don't know. I mean, maybe it starts here. Maybe it starts with ASCE. Maybe it starts somewhere else. Maybe it starts with commissioners putting pressure on the legislature for Florida Building Code to be revised. I don't know, but we need something. We really need something in the state of Florida that kind of guides all engineers. Professional engineers requires us to be professionals. We really have to stick to our integrity, stay within our lanes of competence, call out on each other, lean on each other for expertise. Again, we're protecting some very, very valuable property here. Building departments, a lot of them just kind of wash their hands like, we don't have any code. There's a lot of municipalities that have local codes and local ordinances. They should be considered. And then design minimums, full hydrostatic loading, wave impact design, and corrosion resistance are really kind of key in our approach. Thank you very much for your time. And I guess I get a few questions or?
On returns, would the composite material stand up to whatever?
I think the composite is a really, really great return material. The caution is that you'd be able to properly junction that to the main wall. It will offer the protection because generally they're not going to take direct wave impact loading, but at the time that you end up building it, converting from one material to another probably won't have substantial enough cost savings. We have looked at differing materials on the returns,
So
but
it would be the corners that you would have to reinforce in some, were they connected, is that right?
yeah, I mean, you could build your main wall and do a few feet return with your main wall and then do the junction and probably be okay. But with the cost of composite compared to the other materials that are out there, if you bury steel and it's coated, that's gonna last forever. It's really when it's exposed to atmospheric chlorides.
What's your name and address? What's your name and address?
Oh, it's Marcia Holman at the St. Croix, 145, South Atlantic.
You mentioned weep holes, and basically you're saying you should, as far as you're concerned, you should design as if you didn't have weep holes in terms of the maximum loading. But your design does have weep holes. What's the value, if you designed the wall to work as if you didn't have them, what's the value of having them?
Well, the value of having them is to make that attempt to unload it. It is a bit of a belts and suspenders approach, if you will. Structurally, the wall is designed to hold that water out there structurally, but there's also a reason that you do want to get that water out of your backyard. I mean, it'll kill grass and, there's all kinds of other considerations. I mean, even restoration of your exfiltration trench storage volume, if you're trapping it back in there, that won't have a chance to flow out. So it is that, but it's not the structural guard.
Yeah. Could you say just a little bit more about True Line, as far as what it is?
Who is familiar with True Line? Okay. True Line is a vinyl, it's basically a vinyl leave-in-place form. They're 8x12 cells, and they hook together, and so it's just a series of cells. You evacuate the sand out of them, put reinforcement in them, and then fill them with concrete, and you end up with a reinforced concrete wall that has a vinyl cladding on it, and it's a kind of a leave-in place. 8-inch thick reinforced concrete wall is structurally what you're designing for. The drawback to it is with hydrostatic loading and a number of other factors, it's about limited to a 14 foot, maybe 15-foot maximum design elevation. So 15 feet hydrostatic load with tiebacks is really where it's limited. Now, we are working both with True Line, I'm working with the University of Florida, and maybe some ultra-high performance concrete, maybe different high-strength rebar. And I heard recently that there is potential for a new product to be debuted that will compete with it and possibly allow higher bending moments so we can get a higher wall. It would be really, really nice to see on the market because the amount of corrosion protection that you achieve with that is really, really phenomenal. And that's why I like it, is because of the corrosion protection.
Ocean View or Ocean Jewel
Yeah.
is one of your clients.
Yes.
That's a shorter wall than the other two that you answered the question for. Could you just give the top of the wall and worst case and the bottom of the sheet?
Yeah, the top of the, as I recall, the top of the wall was 12.5 matching existing. Part of the wall was destroyed, requiring horizontal reinforcement of the True Line wall, and then the other part of it is backed by the existing wall, so it has that resistance to the horizontal load. And I actually am not privy to I don't know what what the cost was. That's all being handled by Keystone. I'm staying away from the administration of the project so I can answer contractors' questions, because they all call me and say, where do I gotta be on this? And I'm like, I don't know what the price is, but what do you need to know technically to do this? It's a nice position to be in.
You have some type of a ballpark idea, right?
Well, may I? Okay. I just asked permission from
Okay.
one of my clients. We did a hybrid wall, a concrete core that came in at 4,800. That's a elevation 20 top. And then the adjacent walls were 3,200, and that's for, that was for a straight true line wall, because they have a high 20, and then they have wing walls that are at a lower elevation.
And do you have a concrete cap?
On the true line, yeah, we have a reinforced concrete cap. We reinforce with basanite or pink bar.
That's what I was gonna ask you.
Yeah, we only use fiber in our
You
caps.
use fiber or steel?
In our caps, we design solely with fiber, with steel in our caps, because of the corrosion problems.
I
Yep.
think that makes sense.
There was one in the back. Thank you for your time, and Commissioner, again, thank you for having this. I mean, it's very good for the community. Thank you.
Thank you, Jeff. I guess maybe, are you ready, David Holland? David, his company is Olin Hydrographics, and he's the engineer on the blue-green properties, the 3 timeshare properties here.
Hey guys, just want to start by saying, you know, I get to go to a few of these community meetings and such, and condo meetings and association meetings, and you guys should really consider yourself lucky having someone like Richard on the board that's fighting so darn hard and getting as much information as he can and following through, and he's very knowledgeable on seawalls. And it's really a credit to the community that he's putting this kind of effort in to try to basically get you guys together to save you guys some money. So that's to be commended. So as he said, you know, I'm an engineer. We work let me just start this thing. We work all throughout Florida. We work in the Caribbean. You know, we do everything from the coastal engineering, waterfront. We design big marinas. We do the surveying, mapping in-house, the boundary surveys. We do all the permitting for the walls, coastal construction, DEP, you know, wind wave model studies, everything like that. And I'm a treasure hunter, shipwreck investigations. So I have all the toys and tools and boats to go map the seafloor. Naturally turned that into some fun stuff too. So a couple jobs that we've done. I don't know if you guys are familiar, like Fisher Island is one of the, you know, highest per capita income communities down in Miami. It's a private island. Lots of billionaires live there. You know, we design like their overwater ferry terminals and a lot of their seawalls and things, and a couple of, you know, I've done hundreds and hundreds of inspections, underwater inspections, diving inspections on every type of seawall, from steel to composite to aluminum to concrete panel, and seen walls that lasted 40 years, walls that failed after 10 years, walls that failed after 3 years. So I get to see a lot in my work. So it kind of helps from a construction design point of view, seeing what works and what doesn't over the years. You know, as I said, we do every type of design. When I go into my homeowners association meetings, the one thing I tell them, it's like, you know, if you don't need a new wall, I'm not going to design a new wall. We'll repair the wall that you have. We'll look at the cost estimates. And I typically, in my designs, I don't give a one size fits all. For the Sea Breeze, the Fantasy 2, and the Dolphin properties, that the ones we're working on in Daytona, I designed the wall 3 different ways. I said, okay, let's give us, you know, a least impactive, quickest install cantilever option. Just come in, drive the sheets in, do the numerical calculations, get this wall in as fast as humanly possible, and then to save some money, let's do a much thinner sheet that's a shorter sheet, and let's tie it back and put in conventional deadman anchors. Let's put in some some helical anchors. Let's look at some different options just to get some pricing from the contractors to maybe save them some money. Some of the walls I did at Fisher Island, we had 6 different design options that we bid, and we chose the one ultimately, and it saved them a bunch of millions of dollars, and they were pretty happy with that design approach. One thing that's changed, it's been a bit surprising in the costing operations in doing this. They have a contractor, Brock Mountain, came in from North Carolina. They were on boots on the ground day one, came in with first on site. Really good group of guys, just showed up with the equipment. They got temporary walls, brought them down here, and immediately shored up the property. This is a oblique angle. You can see all the filter fabric that was placed down and towed in, and then they came in and drove right off the truck, drove temporary sheets they had between 19 feet long, 23 feet long, and stuck them out there. And we anticipated, since they're going through this cost and effort of driving it, we anticipated the structural capacity of that wall, and rather than going back and yanking it all out, we went in and just pushed it all down, and were able to get a thinner sheet and and shorter sheets for the final wall design. But this was about, these designs were about speed, about, I mean, I had my designs done back in December. I think we took each wall, the modeling, everything completed. We only do a few projects at a time, so we were done with the modeling work and the final design drawings within 2 weeks of getting the green light to go. And then a 1 week for each subsequent wall. They're all very similar, slight changes in elevations and sheet sizes and things like that. I won't go into all the calcs and the structural calcs unless it's seen. I think we answered the questionnaire, but I'm happy to answer questions when it comes to it with the specific details. We were able to get permits under the emergency order to put the wall back to the same elevation. Does that mean if the old seawall was down at +10 and they built the CBS wall on top of that, another 5 feet, what's the elevation of the existing wall? Well, you know, technically it's all seawall, so we went and got the entire elevation there. We built it according to what the maximum CBS wall was, and so our new sheet pile wall handles all that without the need for a weaker landscape wall, if you would, to get the elevation up. And they allowed that under the order permit. This is the Dolphin Beach Club. It was a unique one on the 3 in that it already had a section of steel sheet pile with a return wall on the north side of the wall. And that section of wall held up very good in the storm. I was actually called in prior to the second storm, for the first storm, when the walls, you know, I did seawall inspections on them, and we saw some, you know, discrepancies and gaps and things that had opened up, and they asked me, hey, are our walls gonna be okay for the rest of the season? And I said in my reports, I said, hey, you guys, all you need to do is take a look north, take a look south, the properties that have the same kind of wall or similar type of wall as you that were made way back when, and see that most of them failed. And I think if these storms went any longer, you probably would have all lost your wall. Thank goodness I said that, because fast forward to this second hurricane, they all lost their walls. So that was pretty much, I think they were like, well, you're our engineer, so let's go to town. You know, these designs, as I said, we did them all the different ways with thinner sheets, tieback, and without cantilevers. And ultimately, the client, they wanted to get these things done, put them in. They didn't want to impact the pool designs or any of the landscape architects. They wouldn't want any coordination and surveying the tiebacks and kind of missing them with the pile supports for the new pools and things like that. So they said, get this thing in. And incidentally, during this process, I said, guys, Brock, talked to another couple contractors. I said, hey, what kind of savings had we gone the other way? And there was a time that, like, you know, when it looked like we were gonna have a little bit of time, you know, what's the deal here? You know, typically over the years, last 10 years or so, you design a sheet pile, if the cantilever has to be bigger, it has to be beefier, and then when you come in with a tieback wall, it's a thinner sheet. You spend a lot of money on steel. The cost of steel right now is almost doubled in the last couple of years. So that upfront cost of buying all that extra steel really hurts. But guess what? The cost of labor has also gone way up. And now with all the contractors and everybody and their brother being busy, it ultimately came down to, you know, could we put in a tieback system with lesser sheets, but now we have this new labor cost of all the digging the tiebacks in, ordering all the tiebacks, pouring, forming, doing all that, or putting in the directional ground anchors or something. And ultimately, the contractor, several contractors said, At this point, it's a wash. It's the same price to come in and drive a thicker steel sheet pile cantilever by itself, get in, get out, put a cap on it, be done, as it was to do the save the money on the sheets, but then spend extra money to do the labor. And there's the unknowns of what they're gonna find when they're digging, or conflicts, playing with the tide, as they put it to me on the phone today. Time is money, and when you're dealing with tides and you're trying to do all this stuff, and you can only work during certain hours of the day, like in Daytona, that they just prefer to get in and get out. And that may not be everybody's experience as an engineer, but in the guys that I've talked to all kind of are in agreement right now, which is kind of changing the face of these kind of designs. So anyway, we came in, we put in all the temporary walls, got that in very quickly. I think one of the things that was interesting on a section that was near the neighbor's wall looked like it was going to collapse, and so they had a small gap that they didn't put in the temporary sheets. They laid some sheets down at the toe, and then they had the filter fabric up, and the waves were breaking on that. You know, not a long-term storm fix, but just certainly a good blow or big 7 or 8 foot wave day. They brought in this piece of equipment, the pile driving system. They're able to get, even with the tides and everything, they're probably getting 70 foot per day. I think a 10-hour day, they could get 120 foot if they didn't have to deal with the tides and access for the beach. So that's a piece of equipment that they immediately shipped in from Germany, got here in about 4 days. From, I think, maybe I'm wrong on that. From the time they ordered it, shipped here, I think it was within a week, so. But anyway, this thing really just goes, picks them up, drives them, goes fast. You know, here's some of the numerical models. We use AM retain. We use a combination of some experience over the last 20-something years to design walls. By the way, sorry, I went to University of Florida too, coastal engineering, master's degree, go Gators. But you know, use a combination. The science of a seawall design is not overly complicated if you do this kind of stuff every day. So we can get a model run done very quickly. I had him do some cantilever options just to present at the end here for you guys, just in a 10 minutes waiting for the meeting to start. So you know, you have your different elevations. We won't get into this, but you have your active wedge, you have your passive wedge, and if you tie back system, you have to get back far enough from the wall to get past that failure zone. That's pretty much the design. I think right now, if I'm a homeowner and I'm sitting there without a wall protecting my property, looking to go into hurricane season, what I've talked to Brock Mountain and a couple other contractors, but what they can do is they can come in with a temporary, right now, tomorrow, start driving sheets at your property under a temporary fix. So what we would do is we would specify a sheet pile that would work in the cantilever, you know, probably like an AZ-22, which basically means it's not really heavy duty, it's not lightweight, but you don't have to go as high as we did at our properties, at most of the properties, at about a plus 12. You put about a 30-foot sheet in the ground, and they could come in and they could drive these sheets immediately, and for about $2,000 on the low end, if they're just putting a sheet in and getting you through, then you get your permits done and have somebody else come in, or they could come in at a later time and build your final cap and have your engineered drawings. But the temporary at that point would basically become the permanent, but it would be done very fast. And I think they can get materials. They told me very quickly. Eric is somewhere here. I don't know where Eric, there he is. So, you know, that's something we talked with Quincy just this afternoon to see how quick it could be done. You know, that's every job is a little bit different, but we could have the design done to where you're putting your temporary wall and that will ultimately become your final wall, and we could do that very quickly for you guys. I guess questions? Anybody specifics? Yes, sir.
I thought the temporary walls could only be 4 down, 4 up.
Temporary walls, as far as I understand, I didn't think there was a limit on the temporary walls and how it could be done. Correct me if I'm wrong, but we put the walls in and got them approved, and we basically offset our temporary wall behind where our new wall was going to go, knowing that we're going to come in with a bigger, beefier section, because that's just all they had available on the side. But as far as I'm aware, I don't think there are any limits on how you choose to protect your wall.
I'm from Sanibel,
Yeah.
3799. But,
Yeah.
my understanding was temporary was only 4 down, 4 up.
for final sheeting, was a lot.
Yeah, I have not heard that specific from anyone, and correct me if I'm wrong, and certainly we could follow up. Go ahead.
Jeff Anton, Technical Engineering. Gentlemen, is correct, the rule is written that way.
Mhm.
You're correct,
Mhm.
you did the right thing,
Mhm.
because you put in, same thing happened on a few of our projects, we did put in larger sheets,
Mhm.
and, DEP was very busy and not really, they had people in the field checking on these things, they were getting slammed from every direction, but the approach, I admire the.
Yeah, well, we went to the DEP, my permit guy told them what we were doing, and as an emergency order to protect this, as the sheets we have, we're putting them in. He said, absolutely, go quick, get them in.
You had a conversation direct with Doug Aarons, and he's kind of like, that's not what I should say that.
Yeah.
Quick question for you, okay, so you put the steel in, it was bit coated, or?
Yeah, they coated the steel. The sheets that came, the temporary sheets were coated, and the new sheets are all coated.
And are you recoating or doing anything to treat them after installation, or is?
Well, right now, they're completely, I don't know how many mills off the top of my head, but they're coated from the factory. They're ordered, coated, the final sheets. They actually had these other sheets from other jobs that they had stacked on the truck, and I went out there and measured everything and looked at everything for the temporary. But yes, once you, the more coating you put on a seawall, and one of the things you see is all the guys, they like to paint the seawall different colors to match their building stuff. That's great. It doesn't hurt. It's good. It prolongs the life of it. I don't know off the top of my head what it is, but for every little bit of coating, I think they said something like 25 years, you increase the life of a seawall by coating it versus not coating it. You certainly don't put exposed steel out in the salt environment in Daytona or this area. It will not last if you don't coat it.
Nice work, I admire it.
Yeah, thank you, appreciate it. And the weep holes were an interesting thing. All the behind the wall, it's all sand. It's this compacted sand and all that, and the drainage properties and all that. We had the thing: do we put weep holes? What elevation do we put weep holes? All that, but we ended up going, putting weep holes in as well. I think it's a prudent thing to do, and it's not going to hurt you. And it certainly. All the walls that I know that have failed down in South Florida area, typically after a big rainfall event, and typically they don't have weep holes, and that is most of the walls that I've seen failed. If they're not undermined or lost, then it's the hydrostatic pressure. Over the years, your tieback system will corrode, will fail, will weaken. And as Jeff said, I mean, walking up and down those beaches, you could see, okay, that one lost its tiebacks, got too old. That one, the toe wasn't driven enough. That one, was just old. But you could sit there and see every single type of wall that failed and see, like he said, engineering 101, the mistakes that were made, or just the length of the structure was exceeded. And frankly, we've been very lucky. You hear talk about 50-year storm, 100-year storm, all this. Guys, this environment's changing. I'm not a sea level rise or not. I mean, I've been surveying for however many years. It's not changing a lot right now, but who's to say what it's going to do? But one thing that is happening, I think all engineers would agree with, the storms are getting more frequent, more powerful. And what used to be a 50-year storm or a 100-year storm, what used to be not a big storm, that's a typical storm. Now it's going to be a 5-year storm maybe. And just because these big storms have slammed into South Florida or Fort Myers or whatever, just as much of a chance in any given year that it comes straight dead center category 3, 4, 5 right down Daytona. I mean, it's just the luck of the draw. And we're using hand casting for the frequency for it to occur. It could happen, guys. Any of these storms could go any which way depending on the weather pattern. So just keep that in mind. Don't feel that you're safe just because it hasn't happened in 50 years. So that's my take on it there. But yes, sir.
Could you address economy of the scale a little bit? And
Okay.
Starting out, in round numbers, my understanding, the fuel cost is approximately $2,000 a foot.
Yeah. So for the big cantilever type wall is about $2,000 a foot for the ones that we used, higher than most homeowners would typically need. Labor cost approximately $3,000 to come and drive all that in. I think You know, and I spoke with Brock a little bit about it, if they had several thousand feet to do, that cost could be lowered to $4,500, and if they had 10,000 feet to do, that cost could be lowered to $4,000. And that's for the heavy, tall, beefier wall, you know, and it's, like I said, the temporary, that's installed, cap, everything put in there. If it needs to be done, you know, with a lesser sheet, I think it's AZ 22, I think we used like a AZ 28 there. But if it has to be a AZ, I'll just tell you 2 seconds here. AZ 20 with 2.3 inches of deflection, you know, 30-foot long sheets, plus 12 NAVD 88, and that could be done for $2,000, just getting it going, getting you done, giving you time to get your permits, get your engineering, get whatever it's done. So we're currently done with our design. We don't have anything. We're not backlogged on engineering work or design work. So if somebody needed to get something done, we could jump on it very quickly, get you a drawing for your temp wall, make sure that the sheets are there, and get something started very quickly. I think we're pretty available.
Is that AZ 22 the material cost?
Yeah, so just to drive right now an AZ 22 30-foot deep, just to drive the sheet in and then move on. That's the cost. Install, procuring the equipment and everything like that.
So furnished install is 2,000 a foot?
Yes,
Okay.
and that's again, that would be, someone would need to come back and put a cap on it. And, you know, return walls would be different. As he said, if you get together with your neighbors, you don't have to do return walls. And that, for every single job, that's gonna be, I don't know what percentage we thought, but it's in the order of 15% or something like that. Yeah.
We're talking about 25 to
Yeah.
80%.
Yeah, it's a lot. It's a lot of return walls, and if you just combine with your neighbors, you don't need them. Him first, and then I'll go over to you. Yes, sir.
I'm not sure. Mark Bariza, 4003 South Atlantic Clover. You've got 100-year storm data in terms of height.
Yes.
I'm interested because, just bringing up return walls, every storm that I've seen and experienced of other folks talking about it, most of the damage, and I forget the terms, it's the water coming from behind, you called it
Hydrostatic force, yeah.
yeah, but
Flanking.
flanking. That's where our damage came from. From the north, and it's always been from the north. Is there any set of data that says that any flanking events or any major surge has come from the south? Because in the setup that we're in, we're looking at 3-4 neighbors that want to.
Yeah, so
I'm on the south end.
Yeah.
So my return would be the south return.
in a nutshell, if you're not the guy that's on the corner that's sitting out exposed, then you know you're basically only worried about the waves that are whatever angle they hit you. That's your face of wall that's going to get it. Your return walls, the reason they say they can be less substantial is they don't have to take those breaking wave forces and such. When we design it, we don't look at from the north to south or whatever. We basically, the main reason for your return walls, if your neighbor fails, you don't want all your sand flowing out the back and then, your wall coming over. Like if you have a tieback system, it's dependent. If you don't have the sand behind your wall, your tieback system fails. And we saw many perfectly intact tiebacks with the rods all still attached, and the wall just fell right on over because that sand went around the sides. They lost the pressure, swirl pressure behind it, and then the wall just went forward because there's nothing. That the anchors rely on that sand being there. That's what the return walls are there to prevent losing that sand. Yes, sir.
Just to clarify cost,
Yes.
2,000, Tom Baker, Marbella. The cost per wall for the materials, 2,000 a foot, right?
Okay, so our project, 5,000 installed with the caps, and it's a heavier duty wall. We were all the way up at plus 16 or so. Let me just tell you off the top. Let me go one to the right. We were up at top of cap. We had a 17-foot NAVD, 18-foot NAVD, 18.8 NAVD. So we're up there a good bit. Other properties that don't have a grandfathered property that had a higher wall or whatever are limited more on the order of about a 12-foot NAVD 88, unless your engineer can convince the powers that be to let you go higher, because those guys get to do it, why can't we?
The hectare
But yeah.
is $5,000 a foot.
That's what we put in for the big heavy-duty wall, really tall. For the option, yeah, for the option for the lower walls, though, only 30 feet long, then there's cheaper options to get them in there. More in the order of 4,000 to 2,000, depending on whether they're putting caps and how long they have to stay on the job. Yes, sir.
Steel and corrosion, I consider steel a sacrificial.
Sure. Over
What's
time.
the life cycle of, these wall thickness? We bump up the thickness to account for
Absolutely.
corrosion losses and
Yep.
some of your final.
Yeah, so that's a good point he makes. We do safety factors on everything as an engineer. Safety factor just means, hey, if I can get away with the AZ-14 section, I know my wall will be stable, it won't fall, anything like that. Well, what about in 25 years if I start to get some pitting, some corrosion? What if my wall isn't as strong as it was? The steel is no longer 3/8 of an inch, now it's a lot less. So what we are required as engineers, we design with safety factors, which means we effectively double the capacity of the wall. We don't design a wall that's just enough to withstand it at the cheapest possible thing. We are bound to put in an extra safety factor, so when that thing is 30 or 40 years old, it will still be standing, even though the capacity of the wall is half what it was. Maybe in 40 years, it's only down to a safety factor of 1 now, but that's why we start. We don't start at 1, and then as soon as it starts corroding, and it fails. So that's basically to the safety factor thing. All steel walls are going to corrode over time. Maintenance done on them, painting them, the surfaces. Don't let surface rust sit there and go unchecked. But that, I don't think, is that much of a problem from what I've seen on the walls on Daytona. People pretty much keep them all pretty painted. That's how we tell how much the sand is moved up and down, depending on where the paint line was, what the sand was when they painted it. So, any other questions, guys? And again, the costs, Eric would be your guy to talk to specifically about these kind of things. These are rough things that for the purpose of the meeting, to give you guys an idea, if you have to do something quickly, to give you an option to get in and get out. That's basically, each job has to, you have to just engineer, you have to know what your eroded depths are, what your elevation is. Each job might be a little bit different, but these are rule of thumb things. So, any other questions? Yes, sir.
If you just repeat the question, you won't have to bring the mic over. Cantilever walls are more expensive. I mean, that's just.
Okay.
And so why did your customer prefer a cantilever wall?
Okay, so cantilevered walls up until this job were more expensive because it took a matter of maybe 35 to 40-something% more steel. Cantilever just means you drive in the ground, it stands on its own weight, it won't fall over, you push against it, you put the weight of the water behind it, and it doesn't fail. It stands on its own without any kind of a bar coming out the back of it and being anchored in your soil or anything like that. As I was explaining before, the contractors are saying now that they can drive these big sheets so efficiently. And it used to take, a big crane and guys getting there, line it up and getting the string line just perfect. And nowadays, these machines they're using, they're putting this stuff in. Literally watching this stuff go in with almost no resistance. They're doing so many feet, and the labor cost is negligible compared to being on a job site and excavating your entire uplands, laying out, ordering all these materials, laying out all your plates, your backing, your nuts, tensioning it. If you put a wall together and you put tiebacks in, you've got to tension every single one of those tiebacks to get the right amount of force on the wall. So what's been happening is they can come in so efficiently and drive these sheets, it just offsets the cost, the more expensive steel, because there's no labor cost at the end of the day. And that's been explained to me by 4 different contractors in the course of the last 2 months.
That's including amortizing the cost of the expensive machine?
Yeah. The machine, I think, is a lease to own or something like that, so they get it quick. So. Yeah, sure, but that machine is included in these costs. And I'm sure they're not going to come out here and lose money. I don't think anybody's in that business. But at the same time, I think, one of my contractors, Poseidon down in Key Largo, they're driving sheet piles down there, cantilevered, same kind of thing, $5,000 a foot. There is no gouging. It's a fair price, $5,000 for a big, beefy cantilevered wall with a nice big cap. That's a great price. So I think, as far as the gouging goes, one note on the surveys. we took it upon ourselves to do 3 boundary surveys for our properties. Had I had a time machine, I would have gone back and said, oh my God, you're crazy. These boundaries were drawn in they were copied over in 1880, hand-drawn, and all of our big properties were made up of about 25 to 30 little 50-foot individual hand-drawn lots, that every single one of them was a little bit different, and that ended up being an absolute nightmare to draw up. And I think our cost on these was on the order of $6,000 to $8,000, I don't remember, to do a boundary survey from scratch. And we had to get records. It took 3 weeks to get the records, just ordered. I had to come up a couple times. But, you know, we lost money on all these boundary surveys. So I could see the guy saying $25,000 is a bit excessive, but I definitely could see that this is not your house's $400 surveyor will be here in a month and give you a quick boundary survey when you sell your house. It was quite an undertaking. I spent almost a week and a half just shooting control points and boundary markers in the field alone, just to get this all, to sort out all the errors in the drawings. That's basically what it came down to. So anyway, hopefully, any other questions, probably somebody else needs time, so. Thank you, guys.
Is Ryan here? Ryan's not here, okay. John, do you want to go next? John Taylor is a resident of St. Martin's, and he's one of the people on the ad hoc engineering committee.
Thank you.
All right, thank you for everyone, and thank you, Commissioner Bryan, for arranging this. Thank you, Daytona Beach Shores, for the facilities and the assistance also. My name's John Taylor. I've got a degree in chemical engineering. I've worked roughly 40 years in chemical and environmental engineering. I was heavily involved in permitting and landfill design and construction, wastewater treatment plant design and construction. So that's my background. I recently retired about 2 years ago and retired to Daytona Beach Shores. And now I kind of work for free, volunteering at church and with the city. Let's see, again, I'm a resident of the St. Martin condominium, and I'm not a seawall design person. I'm not touting any one contractor or anything like that. I'm not a coastal engineer. But I just want to kind of give you what we're doing, and I'm not necessarily representing St. Martin. I'm just a representative who happens to be here. I'm not an HOA board member either, but I have discussed this with our HOA, and they're fine with me divulging this information. And it's nothing, you know, it's all public information basically. And the St. Martin. First of all, the factors on seawall failure, this is just my perception. I walk the beach, you know, just about daily, maybe 1.5 miles one way, 1.5 miles the other way. And like he said, this is Seawall 101. You can look and see the root cause of a lot of failures. And some of the factors that just intuitively to me, first of all, the age of a lot of these seawalls. Again, we don't have a lot of good documentation. There's not like as-built for some of these seawalls. We don't even know how old they are, a lot of them. And just off the top of my head, a lot of them are clearly maybe 60 plus years old. And if you think about it, roughly, 6.5-inch concrete panel that's lasted 60 years on the beach, that's a pretty good track record considering. And then if you think about it, these tiebacks were probably originally installed maybe 60 years ago, you know, kind of a rebar construction. I'm sure that a lot of them essentially were the equivalent of a sewing thread by, you know, 60 years later, and were serving no purpose as a tieback. And if you looked at a lot of these pre-existing walls, I didn't see many that had weep holes. So that seemed to be an issue also. And then I'm sure 50, 60 years ago, whenever these were designed originally, they didn't intend to have someone put a 5, 6, or even sometimes 8-foot concrete block wall on top of the pre-existing seawall. So they were never designed for that in the first place. So to me, that would be an issue also. And then the newer properties that inherited pre-existing seawalls and didn't change them out, they ended up putting in stormwater management systems that put thousands and thousands, maybe even millions of gallons of stormwater behind that seawall. And if you remember Ian, we had, what, close to 20 inches of rainfall. So those soils were completely saturated. There was no place for the water to go, so there was an awful lot of pressure on those seawalls with no loopholes. And then, if you think about it, a lot of these seawalls probably had a decent chance of standing up to maybe one hurricane. That was what I call a drive-by. Typically, a hurricane is not going to sit there offshore for 20, 30 hours. But we had 2 back-to-back hurricanes that each sat out there for anywhere from 20 to 30 hours. So it was just a constant pounding that you're not normally going to be seeing, and hopefully we never see it again in our lifetime. Let's see, and then also, I don't know any HOA or property owner that really was on top of preventive maintenance on seawalls, replacing tiebacks, cleaning out weep holes and so forth. There's not that many that were doing that. So a lot of these seawalls never had any preventative maintenance to begin with. And if there were cracks in the seawalls, they may or may not have been filled in. So those are some of the factors that may have had some root cause for failures. Now, as far as our condominium, some of the issues we were dealing with, if we had to do it again today, knowing what we know now, yeah, we probably would have changed course a lot. But we just finished back-to-back hurricanes. We had complete failure of our seawall. Our swimming pools collapsed also. So we've got loss of swimming pools. We've got loss of seawalls. And a lot of you know that if the erosion of your property is within 25 feet of your property, of your building, there's a likelihood that your building will be deemed unsafe, and you'll have to be evacuated until you get a structural engineer to clear it and say that the building is safe. At our property, right after Nicole, we were at about 45 feet of erosion, so we had a 20-foot buffer to spare. So there was a lot of panic, obviously. Back-to-back hurricanes, you see a complete loss of seawalls and swimming pools, and the erosion is within 45 feet of your building. And you hear of your neighbors having mandatory evacuations and not being back in their building for maybe as much as 6 months, like say at the Hawaiian Inn. Excuse me. So these were issues that we were dealing with. And I think the consensus was that we wanted something done, and we wanted it done right away, and we realized permitting was one of the main obstacles. So we wanted to make sure we got something designed quickly so we could get a permit in place, permit application, and hope for the best for getting it approved in time. And the goal was to have a seawall up and running before the next hurricane season. Obviously, that's very challenging. Another thing is, a lot of, like in our building, we have over 100 owners in our building. So, and we have reserves that are pretty sound, were pretty sound prior to the hurricane. We felt we were financially sound. In the history of the building, which was built in about 2006 or so, there was never a single assessment in the entire history of the building. So really well run normally. But then you have the 2 hurricanes, and now all of a sudden you have to have assessments. You have to get money. No one's going to build a seawall for free. They're not going to order materials and put it on a credit card. So you have to pay up front, and in our case, we had to pay 70% of the cost up front. So we had to collect assessments from all our homeowners to come up with the money to order materials to even get started on building a seawall. And then we're finding that we have a lot of supply chain issues. Something, in this day and age when you can order something on Amazon and get it the next day, well, that doesn't happen with materials for a seawall. I believe it's somewhere from 6 to 8 weeks where we've been waiting for our panels to come in. And for our building, we ended up going with East Coast Marine and LAV. And they work together in coordinating the design, the permitting, and construction of the seawall. The model they used indicated that a 24-foot panel would be recommended. Our panel is a composite panel that we're using. It's called a UC95. I've got a spec sheet on that. And again, on the permitting, you're probably well aware that your seawall, you're not likely to get approval for a permit that exceeds your pre-existing height. So that was one of the driving forces of the 24-foot panel. Our height is somewhere around 13 feet NAVD. So the 24-foot panel was what we spec'd out. And then in our engineering and contracting companies, they're also the ones who are working to redo our pools, and the code requirement for the pools is they have to be on pilings. We've got a design for redoing our pool with pilings. Our stormwater system was completely wiped out, so they're redoing our stormwater system. I can't remember the number off the top of my head, but I think it might be like 26,000 cubic yards of backfill is going to be required. So swimming pool design, stormwater system redo, backfill, seawall cap, and everything were in the order of magnitude of somewhere close to $3,000 per linear foot. Our seawall is roughly close to 500 linear feet of seawall, and we have a we have a unique problem on ours also, where the property to the north of us, as you mentioned, the north side is your most vulnerable. The property to the north of us, they haven't done anything since about COVID. It's kind of an abandoned hotel, so to speak. They do minimum to get by, but in January they filed Chapter 11. So we have to assume that they're going to do nothing, and we're going to be exposed on the north side. So because of that, we have a 95-foot return wall to protect our north side of our property. And these contractors that we've had here, they brought up a lot of good points, and I really appreciate what they've done and in their presentation and the information they shared. One thing that no one did mention that I think is an important factor to consider also is the safety record of your contractors. I would recommend looking at that and make sure that they adhere to safety requirements. You probably heard, what was it, about a month ago or something, that a lady was killed in Daytona Beach shores when she was run over by a forklift. So I'm sure no property owner wants to deal with a fatality at their site. So please pay attention to safety also. I'm going to just go through some simple information on ours. The total cost on ours, this includes return wall, it includes, like I said, the swimming pools designs, the stormwater system rebuild. I think it's 26,000 cubic yards of backfill. We're roughly $1.75 million, of which we needed about 70% up front. Let's see what else you got here. The contractor that's building ours, they're also building the seawall at the Hawaiian Inn. So if you walk by the Hawaiian Inn, you can see an example of their work. Are they the greatest contractor in the world? I really don't know. The Hawaiian Inn, they started off gangbusters, going real fast. They kind of hit a slow peak, and I was wondering, hey, did we really do the right thing here or not? But in the last couple of days, they picked up the pace. They're doing a little bit better, it looks like. Even though our properties are distanced only by 2 or 3 hotels. The Hawaiian Inn is going with a 20-foot steel panel, and we're doing the 24-foot composite panel. So even though the same contractors and not too far distance, it's 2 different designs for whatever reason. And basically the engineer from LAV said, that's what the model showed for each property based on soil conditions and building proximity and so forth. The Hawaiian, I'm not sure of the structure of that building. It's, I believe, a 4, maybe 5-story building. Not sure about the foundation of that building. I think it was awfully close to being undermined. On our building's relatively new construction, roughly 2006 or so. We have a foundation that includes footers that go down approximately 40 feet below surface. So I've been told by the original design person and some structural engineers that even if we had complete erosion under our building, it would still stand. I would never want to test that and prove them right or wrong, but at least we feel a little secure about our building soundness. Again, the top of the cap is going to be roughly 14 feet. Our current sand level, at the time of the survey, our survey was done maybe in December or so, the sand level averaged close to 2 feet NAVD, which is not a whole lot. That's close to zero, no sand at sea level, basically. Since then, we've gained maybe a foot or so of sand, so that's good news. And if you remember, between Ian and Nicole, we lost, with Ian, I can't even remember, maybe what, 4 to 6 feet of sand vertical. But before Nicole, we gained maybe half of that back, it seemed like, and it was very promising. Then after Nicole, we lost, just as much and more back, so it was, very devastating, obviously. Looking, the bottom of our sheet is going to be -10 NAVD. Let's see if there's anything else. And we're going to have tiebacks, not tiebacks, but yeah, the tiebacks are going to be helical rods. Let's see if there's anything else here. I think that's the main things I have. And I do have a info sheet on the UC 95 panel. I'll just see if I can find that real quickly. So this is the information on the panel. It's like a Z shape. It's roughly 1/2 inch thick, 0.54, I believe. And the section widths are 30 inches. and just some basic information there. And I've been told by independent structural engineer that it's a good panel, so it's nice to have that independent third party at least, give kind of a blessing of the panel itself. And again, the materials of construction, historically we've seen, I think the 6.5 inch was the previous concrete panels, and I believe most contractors are going up to 8.5 inch if they're going to use concrete. So if a 6.5 inch lasted 60 years, 8.5 inch with new technology and possibly fiberglass rebar instead of steel, who knows, that could last forever. Certainly a thick steel panel is going to do well, and a lot of people are going with the composites, so I can't be a judge of which is better. It seems like all three have their potential applications. I think that's about all I have. Any questions, or? Yes, sir.
I want to clarify one question from you. You basically said that it was about 1,759,000 for your completed job, right?
Yeah, roughly, yeah.
Thank you very much.
1.75 million ballpark.
Got you. Thank you, sir.
Any other questions?
Yeah, what's your fallback plan? If you don't have a seawall?
Well, yeah, if we don't have the seawall in place. I think the fallback plan right now is with the county offering the 2 trap bags. I would highly recommend putting one on top of the 2. So the one on top of the 2 would be at our expense, and my understanding is the county will provide the other 2 as the base. I would highly recommend 2 and then 1. And then we met with the trap bag person, and one thing that he was specifying is when people backfill their trap bags, they typically fill to the top of the top of the trap bag and slope it up. His recommendation is only going halfway up to your top of your top trap bag to put less hydrostatic pressure on the trap bag to, if the soils become saturated. So I would recommend that also to our HOA. And I've had discussions with the president, and he's on board with those discussions. Could we do it in time before hurricane season? I don't know. But that's our fallback plan. Yeah, and right now our contractor is telling us that he's got us in writing saying we're going to start before the 24th of April. And they're doing the Hawaiian, and it's only, 100 or 2 yards from our property. So in theory, he could start while he's finishing up the Hawaiian.
The price per foot you had down is 3,400. Does that include all the, it's not just the wall?
Yeah, it includes the cap, it includes the helical rods, it includes the backfill.
Yeah, that, okay.
Yeah, it does include the backfill, yes.
Do you know what it is for just the wall and the?
No, I don't have a breakdown on that. I'm sure it's available, but I don't have that information. And they're also doing the engineering and rebuild of our stormwater system, and they're designing our pool structure foundation. So that's all included in that number also.
Thank you.
Yeah.
I just want to make a statement. I've been building seawalls here for probably 40 years. Edwin Peck, and I'm short here. There's been a lot of talk about the weep holes. We put in weep holes, and the state has prevented us from doing it and made us patch them back up.
Yeah.
So there's a state requirement that you cannot have weep holes, which allows drainage onto the beaches against the law to do that.
Right.
That needs to change.
I agree 100% on that. I agree. And I think it was Richard and the gentleman, Alton, I think. I think they all mentioned that you have to design for saturated soils and assume no weep holes, but those weep holes are definitely better than nothing. You've got to have weep holes, in my opinion. And I'm not a coastal or structural engineer, but you know, if I have anything to do with it, I'm going to make sure there's weep holes. And I don't care what the DEP says. I mean, I'd beg for forgiveness later or whatever. I just think it's real critical. And if you look at those seawalls, a lot of them have collapsed into the ocean and not into the property. And that's from the hydrostatic loading of the saturated soils pushing them out to the sea. So that just shows the importance of the weep holes to me.
I agree with you. I agree with you. I've been installing the weep holes here regardless of the law, and if they come back against me, then I'll deal with it at that point.
Exactly.
I would say install the weep holes and deal with the ramifications of the law later.
Yeah, and as you bring up also, it's important to have preventive maintenance. I know our design engineer and contractor have said they're going to give us a PM program for cleaning out the weep holes periodically. I don't know, quarterly inspection, annual cleanouts or whatever, but they're going to give it, and you know, we're going to assign it to our maintenance guys, and hopefully it'll continue and get carried out. I don't know if that's true or not, but as long as I live there, I'll try and make sure they do it at our building. Okay, thank you very much. I really appreciate it.
Thank you, John.
I didn't close it out.
Oh, it's okay. There were two other people that actually answered the questionnaire. So I'm going to skip over them pretty quickly. One was Twin Towers. They've actually started construction now, and they're using the same UC 95 that John just talked about. It's a composite design. The engineer, Adams, Chuck Adams, CRA, and they expect to be finished before the end of May. So I'm not going to say a lot about it because if they wanted to make the presentation, they could have been here to make it. I don't think there's a lot that's unique about it other than the fact that they're one of the first people to actually start construction. They're the ones that I mentioned that are next to you guys, Twin Towers. You guys are looking at steel. You guys being Grand Coquina. I'm sorry. I know you're Marbella, but Grand Coquina is right next to and they're going to have a steel return wall and a composite return wall. 50 feet, or is it more than 50 feet? So, you know, that's 100 feet that you wouldn't need if you'd been able to put together on a common design. The other presenter is from New Smyrna. I do want to talk about that because the main point I want to make about that is that, as I mentioned earlier, this community down there with about 36 homes and one condo actually got together and said, we're going to build a common seawall. And as I mentioned before, they formed an LLC to basically collect some money to hire the engineer and do the work up front. I think I have, it's on Van Cleet Drive in New Smyrna. Anyway, that's a view of them, which may be hard to see on the monitor. It's 35 homes. So I think their savings is probably on the order of 25%. And it comes primarily from eliminating either the length of the return walls and or the number of the return walls. And so right now their design is a composite sheet, but they're not planning to actually start construction until at least the middle of the summer. So I'm not sure exactly what they're doing as far as temporary armoring. But the main reason why I wanted to bring them up is just to show the advantage of getting together with your neighbors and building a common wall. So that kind of ends the seawall presentation. If there are any residual questions, I'll take them on the seawalls. I'm just going to briefly mention the revetments because I don't think anybody here actually do a revetment. But, well, without even putting up a oh, you have, sorry.
Hi, Ken Meister, 4227 South Atlantic.
Are you in Wilbur by the Sea?
Yes.
I know the chairman copied you on the email to me.
So one of the biggest expenses is the backfill requirement and where the sand's coming from.
Yeah.
And I've asked Jeff Brower to see if they can push the DEP to get us the same sand that they're using for the emergency restoration, the 37 plus 5 million, which I understand is closer, more local sand. Any thoughts on that? Anything that we should know about? Because it would save all of us a tremendous amount of money. One of the big concerns we have with the county right now, or at least discussions, is that they have a 40-foot right-of-way between my property and my neighbor. We want to build a common wall. We have to go across the county's right-of-way. And they're saying to us, we'll let you do it, but you have to pay for everything, which is seawall, which we're willing to do because we can eliminate the returns,
Yeah.
close the gap, but there's probably going to be $100,000 worth of sand, and with the prices that people are telling me that it costs per truckload, which is $1,000, $1,200 a truckload, getting the sand from Palatka or wherever they're getting it from. And if we can get that local sand,
Is that an 18 cubic feet truck?
it's, we
A lot
calculated
of
at 15.
people say per truckload, and they don't
We
know whether it's 12 or 18.
We use 15 in
Makes
our,
a big difference.
you know, we use 15. So, but if you use 18, it might be 8 grand.
Yeah.
But there's 40 feet times 60 feet deep times 13,
Yeah.
10 to 15 feet high. And not only my property, which is 100 feet of that, and plus the 40. So sand in the backfill is a big issue, and I just want to see if there's any
No, it's
pressure.
a big cost. The sand they're using for the track bags, they're getting from what was dredged out of the river and maybe the channel, the inlet down in New Smyrna. So the only thing the county is actually paying for that sand is the transportation costs. And they're not charging the property owners where they're placing the 2 trap bags. I don't know that how much of that is actually going to, whether that's going to go all the way in terms of the 200 properties or so they're planning to put those 2 trap bags out in front. I haven't seen numbers. But they should be able, there should be some way of, quote, getting less quality sand at a lower cost because it's all going to be behind the seawall.
That's what we're asking for, is how can you guys put pressure on the county and the state to help us with that? Because it's just it's a gigantic cost when it sits behind a seawall. We've had 100 feet of property washed away
Oh, yeah, no,
It's a huge number.
it's an issue, and I don't know how it's gonna get resolved, to tell you the truth. I mean, $50 a cubic yard is, it's better to talk in terms of cubic yards, because then you don't have to say how big is the truck. Is the kind of somewhat of a going rate right now.
Richard?
Yeah.
Yeah, two things on that. One, just so you're aware, Richard and I and several others, we presented to the legislative delegation in, was it Land or whatever, I can't remember. And that was one of the things we did request. If you're on the beach side of the seawall, I can understand the need. If you're on the property side of the seawall, the west side, surely they could make some, concessions. We requested that. I don't think anything's happened, just so you know. And then the other thing, I may be wrong on this, but I think our property, we're planning on getting those trap bags regardless, because if nothing else, it gets us 2 layers of sand that we can just empty,
Yeah.
and that cuts our sand costs, even if it's just 10%.
Some people are doing that. They're asking for the trap bags because of the sand. How many feet in common will this, you say there are three properties?
No, there's actually 4, but there's 2 of us next to each other. So we have 100, the right of way, 150 and 50. And this lady just asked me the question about those trap bags. The county, we were told, did a survey and picked all the most endangered vulnerable homes, and those are the ones getting, I think there's 216 or something, if I remember the number correctly. So they've identified who gets them right now.
And
It helps,
I think,
but it's
don't you
not-
have a list of
it's not a lot.
who's getting them? This is, I just put up a sketch of the county trap bag. They're basically 2 trap bags side by side. They have a little scour prevention skirt out in front, and and those are the dimensions. They want those trap bags placed up near the escarpment, so it can't be out, far away.
So regarding the trap bags, the easement the county is asking for is actually 2-part. It's for the trap bags and sand, plus for future beach nourishment. So the county received $5 million in the initial governor's request. That is being used towards the trap bags. And one of the things I would tell you, yes, they identified, call it 220 odd properties. If they're able to stretch that, if they have your easement, and on a first come, first served basis, they have said if they're able to, that 5 million goes more than those 220 properties, they will be placing them where they have an easement. They have another 37.6 million to do a beach nourishment study, and that includes both sand placement, possibly right up on the beach with trucks. There's some discussion that DEP or EPA, or I'm not sure which agency, is going to make them do it in what they call near shore placement, where they dump it in the water and the water puts it up on the beach naturally. But where I'm going with that is there is money, and they are trying to hit as many properties as possible. You can have the discussion, as Commissioner Bryan and I think a couple others have alluded to, well, is 2 trap bags enough? It's 2 trap bags full of sand that will hopefully, if we don't get a hurricane, you can use either behind your wall, but also it's that future beach nourishment, because one of the things that the county has an ordinance, they've deferred it to December of 2024. If you do a seawall repair, they have a local county ordinance that says you must do beach nourishment in front of your seawall as well. They're hoping that with that grant money, and they're hoping to get, DEP suggested they have 77 million. They've gotten 37.6 of that 77 million funded already to do just that. And they're hoping that would be in front of your seawalls for those requirements. So look at it as an opportunity to get free sand. Give them the easement unless you have some absolute hate for the county for some reason.
They denied you right now.
But yes, but
But I should still fill out.
still fill out that easement because the future beach nourishment, the county right-of-way department is handling all of those easements. Shannon, you remember Shannon's name? I don't remember at the county.
Jessica.
But Stuart can answer the question. Actually, he may have the easements. Stuart has them. Yes.
So, I'm Dan from Will Berwick. Most of us are here anxiously awaiting a permit. And if we get a permit prior to May 1st, first thing we're gonna do is start construction on that seawall.
Yes.
If construction is started, are they still gonna set the trap bags?
That's a question for the county. I don't know.
Bags right now.
Yeah, if you're on the list,
We have
Okay.
asked for the trap bags right now, but, you know, and we are a priority. But I haven't seen anyone get trap bags yet, have you?
They just started a few days ago.
we have seen some properties out there, and I actually have a 9 o'clock trip planned to go see exactly that on the beach tomorrow morning. But if you have not signed that easement, even if you're not eligible for the first round, I would go ahead and sign that, and it gets you in line, because you don't want to be that one property that didn't sign it, and even if in 2 years, they finally figure out the rest of the money to do that nourishment project, and they come along and you don't have your signed easement, or the county doesn't have your easement, they're gonna skip your property and go on to the next one. So take advantage now while you can. They're good for 5 years. They do have an expiration date. Look at it as an opportunity for a free gift, which doesn't come along very often.
Are you one of the common properties? You're looking for the common seawall? The one,
I'm part of the common seawall.
yeah, okay. Yeah, if there's anything I can do to help, I'm trying to be proactive in encouraging people to do that. I'd be happy to meet with you and stuff. But mainly, if you have a good community organizer, or at least, or 4 people that want to cooperate, that's what you need. And we should be able to work out the details of getting the engineering done, paying for it and all that stuff.
Can I make one more comment, just publicly? One of the things that, if you're still pending on your permit, hound your engineer or whoever submitted your permit. DEP, I know they've taken a bad rap, but they have really stepped up their game in trying to get permits turned around. They are doing actually a really good job of doing it quickly. What we're finding, because I'm taking calls and I'm able to reach out to DEP and Fish and Wildlife and ask, hey, why is this one being held up? They're asking for additional information in a lot of cases, and the engineers are not providing it in a timely fashion. I'm not going to call out any engineers or anything like that, but stay on top of them. If you have to call them every day, you can also follow up. The information is public on where your permit is at. They will take your emails and respond and tell you, oh, there was a RAI is the common term that we're seeing now, request for additional information. So if you don't have your permit and it shows as incomplete on their system, that means they've issued an RAI. If it's pending, it means that they have received a response, but it hasn't been reviewed.
How long does it take for them to
They are trying to turn those around in days. We talked about one today, and they said, here's the one issue we had on the permit. If they would change it to read this way, we can issue it this afternoon. I mean, they are really trying to stay on top of it, and they've been under a lot of pressure to do so, and they have really stepped up their game. So it's not the 4 to 6 months that a lot of people have heard. Originally it was. DEP originally was no, 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 on permitting. No, you can't do this. No, you can't do that. And now, we heard the question earlier, for example, 4 foot in, 4 foot out. They've allowed exceptions. So they are allowing exceptions. They're allowing some exceptions to sand. At least they were. I don't know if they still are, but they were allowing lesser quality sand. And at one point when they were down on Beach Street in the office there, you could bring in a sample in a Ziploc bag of your sand and they would look at it and go yes or no. So they are trying to do things to help you, but my dad was a pediatrician, and one of the things he said, as a patient, your best advocate is yourself, and that applies in this situation. We have some great engineers and some great contractors, and we have some that may have taken on too much work. And unfortunately, you know, our citizens are the ones that suffer from that. So stay on top of them. We all know the squeaky wheel gets greased.
As a FYI, our permit took roughly 30 days to be issued. Our permit took roughly 30 days to be issued, but that was with an RAI from the DEP that we were responsive with. And the RAI, kind of trivial, but we responded, and with the RAI and everything, it was 30 days.
Yeah. And I hate to say this, but DEP does have the rules, and the folks that are issuing these permits have to follow those rules. So you can hold out for your perfect design, or you can get one that meets the rules and get your permit sooner than later. So there are some folks that, no, I'm insisting on this design. Well, you may insist, and maybe you'll get something in 2 years. It's not the answer we all want to hear, but I'm just trying to be as real as I can with everybody. Richard, do you want to wrap it up?
I just want to mention the price of a revetment. Probably only single-family homes can do it. You need enough space. They're like 25 feet that are going in there, 25 feet horizontally, 12 feet. But the kind of prices that are coming in now are something like $800 a foot, which is, and that's for granite. So that's a lot less expensive. You know, it's maybe a third of the cost of a seawall. If you have enough room, it's a reasonable solution, which means you've got, you know, 25 feet that you don't want to put a swimming pool in or whatever. So probably mostly for single-family homes. Most condos want to use that space for swimming pools and stuff like that. But I just thought I would mention that. They got permitted for it. When I say they, I'm talking about the people south of Frank Rendon. There's no guarantee that another property would get permitted for it. But if somebody or some group of homes, it's actually good to get together and do it as a group, because you want the revetments that match up to each other, and otherwise you get into having to build return walls. So I just thought I'd mention the price of a revetment if any of you want to consider it. That's pretty much all I have. I thank everybody for coming, and hopefully it was provided some valuable information.